Hello everyone. In this video, we will cover another trigonometric substitution x equal to a secant theta, and we will do some examples for that substitution. Well, this substitution works when your integral has a term like x squared minus a constant squared, or you can turn it into this form. Then, if you set x to be a secant theta, this will give you a squared secant squared minus a squared, factor a squared. What you notice is that secant squared theta minus 1 can be replaced by tan squared theta. This is the identity we have been using a lot. So that means that under the square root, we are going to have a complete square. So that means that, not secant, tan squared theta. So that way, the substitution will help us to get rid of the square root, but your integral would turn into trig integral, which we covered, and we can do integration for those ones. There's only one remark that you have to keep in mind: the way this substitution and the substitution a equal a sine theta, they look like the same, similar, sorry, not the same. So in the case of a squared minus x squared, we set x to be a sine theta. The reason this worked was that 1 minus sine squared theta was cosine squared theta. And now that we have root x squared minus a squared, then x equal to a secant theta will work, because secant squared theta minus 1 is tan squared theta. See, exactly this point shows that how that substitution works. There's also another thing, that if your expression is of that form, that means that the domain of x is between a and negative a, which exactly matches with this domain here, because sine is between negative 1 and 1. And for this one here, the domain is x is either bigger than a, or x is less than equal to negative a. And that is this, again, matches with this one, because the range of a secant is bigger than 1 and less than negative 1. Yeah? Okay. So let's see this in practice. Here I have a equal to 4, then set u to be 4 secant theta. From there, you see that du is 4 secant theta, tan theta, d theta, and our integral, I can turn to theta integral. In the numerator, we get 4 secant theta tan theta. In the denominator, we get 4 square 16 secant squared theta, and 16 secant squared theta minus 16. Well, right away, even there, we can do some simplifications. This will give me that. This will disappear there. And also under the square root, you have 16 tan squared theta. So we can simplify and write that as tan theta in the numerator, and in the denominator 4 secant theta. Under the square root, what comes out is 4 tan theta d theta. Yeah. And again, some simplifications. The constant, you can take it out and write it 1 over 16 integral of 1 secant theta d theta. This may look a little bit strange integral, but remember that Secant is 1 over cosine, so we will have integral of cosine theta d theta. This is the easiest possible integral. This is an integral from the table of integration, and it is sine of theta. Okay. But we are not done. We have to put back in our original variable. So here you notice that secant theta is u over 4. So if I have a reference triangle for secant, for this equality, for theta, secant is hypotenuse over adjacent. So I can set u to be there and 4 to be there. So as a result, this will be u squared minus 16. And then as a result of that, the sine theta will be, it's always defined as opposite over hypotenuse, yes? So that will give me 1 over 16 root, in the numerator will be u squared minus 16. In the denominator, there is a 16 there, u, and then plus c. Okay. So that is the integral we had, and we turned it back into what the variable, the original variable was. Okay, let's do one more example here. When you look at this integral, the square root term that you have is not of the form x squared minus something square. But you should always remember that any quadratic polynomial can be turned into that form. Something squared minus or plus another thing squared. And that's called completing square. Here, if I add 9 and subtract 9, I will get x plus 3 squared minus 9. And then, okay, so I can use x plus 3 squared minus 9 dx here. I can either use straight, or you just go use u substitution. This is easy substitution because du and dx are the same, and while your integral will turn into integral of u squared minus 9 dx and du, sorry. And now this is of the form u squared minus something squared. So a, there is 3, and we can use the substitution 3 secant theta. And while from there we have 9 secant squared theta minus 9, and 3, the derivative of 3 secant theta is 3 secant theta tan theta d theta. And 9 secant theta minus 9 is 9 tan squared. It will come out of the integral as 3 tan squared. So I will factor out both 3's that we have. The integral would turn to this guy here. So let me just write this thing here. It will give us 3 tan theta. Oh, I dropped this square sign there, sorry. Now that we have this is trig integral, powers of tan and powers of secant, and we want to see how we can do this one, yes? So you look at this one and you notice that well, we have to do some of the tricks that we learned in the previous section. I will use tan squared. I can write tan squared as secant squared theta minus 1 d theta. And from there, well, then just you will get secant cube theta minus secant theta d theta. So the integral of secant theta, we know what is that. Integral of secant cube, we have done several times this integral, but one way to do it is reduction. So the power reduction formula for secant, powers of secant. And let me just write the final result here. So it will be half of secant theta tan theta plus half of ln of secant theta plus tan theta. That's the integral of secant cube minus integral of secant itself is ln secant theta plus tan theta and then plus c. If you do subtraction, there will be a common denominator 2 there. So we will have secant theta tan theta minus this time ln of secant theta plus tan theta plus c. Now we want to turn back everything into u variable. Remember that u over 3 was secant theta. Draw the reference triangle there. So theta is there. Secant is hypotenuse over adjacent, so it will be u. I can put u and 3 there. As a result, what we will get here is u squared minus 9. And as a result of that, tan theta is going to be opposite over adjacent. Okay, so now we can plug in everything one by one. Secant is u over 3. Tan is square root of u squared minus 9 over 3 minus ln of secant is u over 3 plus over 3 plus c. Okay, now we can simplify and write this as u squared minus 9 over 2 minus 9 over 2 ln of u over 3 plus u squared minus 9 over 3. And well, remember that our original variable was x and we set u to be x plus 3. So now let's just put that back in. X plus 3 root x plus 3 squared minus 9 will give you x squared plus 6x over 2 minus 9 over 2 ln of x plus 3 over 3. And what was that one? It is x squared plus 6x over 3 and plus c. So this way we turn everything back into our original variable x, and you saw that how the substitution worked in this case.